The UVLED project was conceived to develop new formulation components enabling the UVLED curing of wood coatings in air. Backed by European Commission funding under the FP7 7th Framework Programme, work on the UVLED project commenced in early 2011, with the key objective of curing coatings using UVLED lamps at the same rate as conventional UV curing, but without the need for an inert atmosphere. The project partners met together in November 2012 at paint and coatings manufacturer Tikkurila in Helsinki in order to carry out comprehensive trials to validate all of the research. In conditions designed to accurately mirror those of commercial production, this short film shows how these application trials were carried out. First, 2 primers were prepared by Tikkurila, one for application by spray gun and one for roller coater. Both primers contained oligomers, photoinitiators and additives found in the project to be best for overcoming surface tack when curing with UV LEDs. The photoinitiators used in the coatings were provided by Lamson Limited, following research carried out at the Technical University of Vienna and formulation work at PRA. The UV LED array used in the trial was designed and built by Integration Technology Limited, using a special combination of different wavelength LEDs and fitted with an inline intelligent control from microglass to switch it on and off only as the panels came under the array. Okay, so let's see how the trials ran, starting with the spray primer. This was a 100% solids white pigmented primer, prepared ready for use and needing no dilution before applying with a low pressure spray gun onto MDF draw fronts for kitchen units supplied by Topi-Kalustaja. As we can see here, the first coat applied nicely, giving a film weight of around 80 grams per metre squared. This panel was then passed under the UV LED array at a speed of 2.5 metres per minute, which switched on just before the panel ran under the array and turned off afterwards. The panel cured well, with no stickiness or surface tack, and was easily sanded before applying another coat and repeating the process 2 more times. After 3 coats of primer had been applied, a single coat of white water-based UV curable top coat was applied. This also cured well using the UV LED array. Next, we ran the roller coating primer. Again, this was a 100% solids white pigmented primer which was ready for use, needing no dilution before applying with a small Berkel's laboratory roller coater onto MDF draw fronts. The first coat applied nicely, giving a film weight of around 18 to 23 grams per metre squared. The panel was then run under the UV LED array at 2.5 metres per minute, which switched on just before the panel ran under the array and turned off afterwards. The panel cured well, with no stickiness or surface tack, and was easily sanded before applying another coat and repeating the process 2 more times. After 3 coats of primer had been applied, a single coat of white water-based UV curable top coat was applied. This also cured well using the UV LED array. All trials were repeated at a line speed of 5 metres per minute with similar results. Both trials ran well, and the applied coatings met all of the requirements from Topi-Kalustaja and the technical team from Tikkurila. Once all of the trials were completed, the fully coated samples were taken away for thorough laboratory testing, including checking for colour, opacity, adhesion and stain resistance. As expected, both spray and roller coated samples passed all of the rigorous tests carried out by Tikkurila. The members of the team would like to thank the suppliers which provided materials for Project UVLED, and especially to thank the European Union for providing the funding for this project. Details of the technology developed in the project are available from the project website at www.fp7-uvled.eu or from any of the project partners.